get started. We got a couple practice examples here. Start with this one. These were all on Smart Side earlier. This is, as you'll see, a combustion analysis problem. We're trying to find a empirical formula. We have a reaction. I made it a little bit different in that this one has sulfur. Usually there's carbon and hydrogen, or carbon, hydrogen, and oxygen. This one also has sulfur, so we've got something like this going on. CXHYSZ plus O2 goes to CO2 plus water. This is 1.086 grams. This is 2.272 grams. And this is 0.465 for water. And so also, the other term you're going to have because of that sulfur will be, it's always the fully oxidized form of the entity, so SO2. On an exam, I'd have to give you that. So the interesting thing, if you add anything besides oxygen, they're solved in the same method as carbon and hydrogen. So because only oxygen is the tough one, because oxygen appears so many places in the products. But carbon appears only once, hydrogen appears only once, sulfur appears only once. Anything else like that would follow the same method. So it's actually easier when you don't have oxygen in the original starting material. Okay, so how do we solve this? We just pick an atom to start with, so let's start with carbon. Carbon comes from CO2, so 2.272 grams of CO2. What we want to do is find the moles of carbon, hydrogen, and sulfur, and that will represent X, Y, and Z respectively. So change this to moles. It's 44.01 grams per mole from the periodic table. And then there's 1 mole of carbon for every 1 mole of CO2. This turns out to be 0.05162 moles of carbon. Okay, so we found the moles of carbon. Again, what letter is this going to be? Yeah, this is going to be X. Okay, next. Now let's do the same thing we'll do for hydrogen. For hydrogen, hydrogen comes from the water. So let's start with water, 0.465 grams of the water. Change it to moles, just like before. From the periodic table, it's 18.02 grams per mole. Then we know that there's 2 moles of hydrogen for every 1 mole of water. Why is that? Because there's 2 atoms of hydrogen for every molecule of water. This turns out to be 0.0516 moles of hydrogen. Okay, again, what variable is this? Y from up here at the top. Y hydrogens. Okay, next. Let's do the same for sulfur. Again, sulfur or any other atom, not oxygen, will follow the same process. Sulfur comes from SO2, 0.827 grams of SO2. Now, molar mass to get to moles. SO2 is 64.06 grams per mole. That's from the periodic table. And there's 1 mole of sulfur for every 1 mole of SO2, meaning there's 1 sulfur atom in every SO2 molecule. This turns out to be 0.0129 moles of sulfur. And this is Z. Z sulfur from the very top of the screen. Okay, we have X, Y, and Z. Now we can go straight to our empirical formula. Scoot down a little bit. We've got, just plug in CX, that's 0.05162 from above. HY, 0.0516. And SZ, 0.0129. So I'm just plugging in X, Y, and Z. I'm going to divide by the smallest, which is the 0.0129. Through all 3. And if you do that, you'll get C4H4S. Remember, you need to be rounding to whole numbers. answer, check, got the empirical formula. They also asked us for the molecular formula. So given in the question, we had, let's see, the molar mass originally was 84.1. So we had 84.1. What we're going to divide by is we're going to take that empirical formula number and put it down here. So we're going to find the molar mass of the empirical formula. When you do that, the empirical formula is 84.142. You can see they're essentially the same, and you get the number 1. Number 1 means what? It's going to turn out that the molecular formula is going to be the same as the empirical formula. You'll just multiply through the subscripts by 1, and you're going to get the same answer for the molecular formula. So there's the same thing. And that's totally fine. Was there a question? Oh, hi. Say it again. Oh, these two right here? Okay. This number on top in the numerator is the given number. It's the number they give you in the question of the molecular formula, the real thing. The bottom one, you calculate always. It will always be smaller or equal to the original number. And this number comes from the molar mass of the empirical formula. So it's always molecular over empirical. The molecular is always given, the empirical is always calculated. Is that okay? So I just use this from the periodic table to get the bottom. Okay, cool, good. And you don't know how to draw it, but you'll learn in chapter 9 when we learn Lewis structures. But this compound is this right here. This is thiophene. Bonds right there. Okay, I had another example. And that was naming, I believe. Let me find that. Kind of two. One thing we wanted to do was finish what we did last time. I wanted to finish, we were working on all these. And then I even had more. And naming just takes a lot of practice. It could be a little disheartening in the beginning because there's so many details to keep track of. So conceptually it should be pretty easy. You just have to get used to all the details. So we just started with the acids at the end of last class. HI is hydroiodic acid. Hydro is always the prefix when there's two atoms. Okay? So if we go to the next one now, this one also has two atoms, so this one also will start with hydro, just like above. And just like the stem of iodine, bromine or brome will be the stem name. And then just like above, ic will be the end. So hydrobromic, last name always acid. In fact, you could fill all these in, they're all acid as the last name. Okay, let's go to the next one. HNO3. You see, in this case, there's more than two types of atoms, H, N, and O. So in this case, it's named differently. Let's take a look at our naming template that you saw last time. An aqueous acid that is now ternary for the two atoms. It will not have a transition metal, but what you do is you have the ion, anion name. And if the anion name ends with ATE, you swap that for the suffix ic. If the anion name ends with ITE, you swap it for the suffix us. And again, the last name is always acid. So this is, what's the name of NO3 minus? Yeah, that's nitrate ion, the nitrate ion. So you're going to change 8 to ic, nitric acid. Similar for the next one. This is sulfite. We saw it up above earlier in the last class. Sulfite, sulfurous acid. And notice some people, it can be a little funny. You're going to use the full name sulfur before you add the us, not just sulfus, but sulfurous acid. This one is sulfate. The next one, move this up a little bit. There we go. So sulfate changes to sulfuric acid, I've seen before in lab. And then here, this last one, we're going back to two atoms, hydrogen and sulfur. So again, I follow the same as before. I start with hydro. Hydro. Then sulfur, just like before. Ich. So hydro, sulfur is the stem. Ich is the suffix, last name acid. So notice that the only difference between the last two is one has hydro. So we have sulfuric acid and hydrosulfuric acid. Only that hydro tells you that there's two atoms. If you didn't see the hydro, you'd think it's a sulfate. Okay, so that's that one. Any questions before we move on? I have another whole sheet to practice. Do that whole sheet now. This out of the way. Remember, look at this stuff online. I've got naming examples 1 through 9 on YouTube. Now I have this set. This set, you will see, is significantly harder than the previous page. I want to pick some tough ones for you just so you can see what they would look like. And they'll be a little bit different. Okay. Oh my goodness, they're painful. Let's start with the second one. You'll see why. Start with the second one. Plumbus acetate. So what element are we talking about here? Lead. Okay, good. Lead, what charge? Plus what? Plus 2. I'll write that down here. Lead plus 2. Plumbit would be what charge? Plumbit would be plus 4. Acetate is C2H3O2 minus. So to balance out the charge, I need 2 minuses to make this thing neutral. So I'm going to do Pb C2H3O2 2. That'll give me 2 minuses, 2 pluses. It'll be fully neutral. That's plumbus acetate. It could also be called, in English, lead 2 acetate. So in English, lead 2 acetate is also acceptable. Okay, if that didn't freak you out, then let's try the top one. Nitrate, let me do nitrate first. It's NO3 minus. That's the nitrate ion. We saw it in the previous page. Okay, mercury has what 2 charges? 1 and 2. Okay? Mercurous means which one? Higher or lower charge? Lower. Okay, here's the crazy. Here's the higher charge, just so you can see. Here's the higher one. That means mercuric. Okay, here's the lower one. Here's the problem. This does not exist in nature. It always forms a dimer, meaning 2 of them go together, which will look like this. Okay? So you need to know that mercury 1, or mercurous ion, is always Hg2, 2+, meaning it's 2 mercury pluses together. The mercury plus is not stable by itself, so it has to form what's called a dimer. So this is mercurous, right there. That's going to go together with a nitrate. We need 2 nitrates. So that would be Hg2NO3 2. Okay? We need to put those 2 ions together. Most people, of course, wouldn't have realized that. That's why I did an example on this one. So now you know what mercury 1 looks like. Next. What category is this in? Now we're going from this to the name. This is called aqueous acid. Okay? So what is this called right there? What ion is that? That's oxalate. Oxalate. So we're going to change that to oxalic. Ich for the 8 goes to ich. Oxalic acid. So this was a ternary aqueous acid, so no hydro, just the anion name with the appropriate suffix. Next. What category is this next one in? That's a ionic, it has a metal, so it's just the first name as is, magnesium. It's no transition metal, so we don't need to worry about Latin or Roman numerals or anything like that, just magnesium. Now this second one you might not recognize yet, but this is called dihydrogen. It's one of those ionics, polyatomic anions you need to know, dihydrogen phosphate. So because this is ionic, ternary, it's each name as is. I don't have to add any special suffixes. It's just that I wanted to add this one in here so you could see how it was named. It's called dihydrogen phosphate. Okay, next. What category is this one in? This is ionic. There's metal. Is this a transition metal? Yes. Gold is a transition metal. It's in the middle part. In fact, I don't think I said it clearly last time. See where the staircase is between boron all the way down to polonium and aconite? That staircase, the red one on these periodic tables, really everything under the staircase will kind of count as a transition metal too. That's why lead and tin are counted as transition metals whenever you see them, like this one. Okay, so this is gold. What's this one called? That's called a dichromate. It has a 2- charge. So that means if this is 2-, what's the charge on gold? Yeah, it has to be +1. So 2 +1s and a 2- make it neutral. So this is called gold 1 dichromate. Or instead of gold 1, you could write AURR, what suffix? Yeah, OUS, it's the lower charge, Aurous dichromate. What's the lower charge for gold is 1, what's the higher charge? Yes, 3. Okay, next, perchloric acid, so we're going backwards from an acid. There's no hydro in front. So I know perchlorate comes from the perchlorate ion. So you just have to figure out what the heck is the perchlorate ion. Well, it's one of those to remember again. It's Cl4- is the perchlorate ion. So to make this the acid, you put an H+, it's HClO4. Remember again, these are the harder ones. So if these feel tough to you, you are normal. Okay? You just need to get used to it before the exam. Okay, hypochlorous acid. So it's hypo, not hydro. So hypochlorous means this comes from the hypochlorite ion. What the heck is hypochlorite? That's ClO-. Hypochlorite. So this is HClO. 2 more chlorine acids for us coming up. So again, we have a ternary, more than 2 atoms for an acid. You know it's an acid because it has H in front. So you just need to know the name of this thing right there. Does anybody know the name of it? This is a chlorite. Not hypochlorite, but just chlorite. So chlorite changes to chlorous acid. Or the last name's always acid. Get partial credit just for writing the word acid on there. Okay, what's ClO3 called? Anybody know? It's chlorate. So chlorate changes to chloric acid. So notice the slight differences in naming this. Perchlorate, hypochlorous, chlorous, and chloric. All different. Okay? Those are all on your list of polyatomics. This is on page 21 reader. It's in the textbook as well. Okay. This one, NH4 plus is ammonium ion, and the MnO4 is the permanganate ion. This is a little funny. NH4 plus doesn't have a metal in it, the NH4 part. There's no metal, but we can still consider it as an ionic. So here's an example. I know the second part has a metal, but the NH4, whenever you see that, it's going to force you into the ionic category, even though the cation does not have a metal. So this is first name as is, last name as is. So it's ammonium, because it's ammonium ion, and this is permanganate, so it's just permanganate. Ammonium permanganate. Next, this has a metal, one of our normal ionics. It's sodium. Last name, just like the up here, the dihydrogen phosphate. This has one hydrogen, so we call it just hydrogen, space, carbonate. This is also could be called sodium, one word, bicarbonate. Also could be called sodium bicarbonate. We know this thing as baking soda. Okay, next. Cupric thiosulfate. So we've got a cupric. Cupric means what charge on copper? Copper is 1 and 2. So it's 2 plus. Thiosulfate, S2O3, 2 minus. So put that together. One of these and one of these will make it neutral. CuS2O3. Cupric thiosulfate. Try the next one. What category is the next one? There's no metal and there's no hydrogen in front. We're calling this molecular. So now for molecular, remember we need to name the prefixes. Or the subscripts, I guess I should say, make them prefixes. So we need to name this 2 and this 4. So we'll say di-nitrogen. Di-nitrogen, again, because it's molecular. Tetra for 4. And then the stem, hyd, for hydrogen. So tetra is the number, hyd for the stem of hydrogen, and then ide as the given suffix. So dinitrogen tetrahydride. The last two, as you can see by the last names, are acids. They're pretty similar. One's hydrophosphoric acid, the other one's phosphoric acid. Top or bottom, which one has only 2 elements? The top, that hydro tells you it's only 2 elements. So that's a hydrogen with a phosphorus. What's the charge of phosphorus from the periodic table? Minus what? 3. So H3P is hydrophosphoric acid. Phosphoric acid, though, is ternary. Phosphoric comes from phosphate, which is PO4 3 minus. And you put that together with an H plus for an acid, and it's H3PO4. See how different these two are. Make sure the hydro tips you off to only 2 elements. Okay, we did it. Any questions on this craziness here? Questions on this? Yeah, way over there. Are there more examples on SmartSite? No, there's more examples on YouTube. So what you can do is essentially, I'll write the question. I have tons on each video. And then you can just pause the video there and see if you can name it. And then, of course, on practice exams, there's going to be one of these questions. It's the same every single quarter. Take a look to make sure that you see what they look like, and that'll give you a ton of practice. So, and of course in the textbook, stuff like that. You have to do practice to get this stuff. There's no way around it. Remember, your TA will be announcing something like this that's on the chem elements. I encourage you to watch the video. You'll see that there's some transition metals we gloss over and ignore that actually you don't need to put parentheses for. We don't really talk about that much in class, but it is covered in the video, and you'll see them on some of the kind of pre-lab nomenclature quiz that you have on chem elements. Okay. Check. We're going to start chapter 4 in just a little bit. we learned 3 of the 4 naming systems. There's one more. This one actually, for most people, is the easiest because we're not going into it in much detail. That's why. It's on YouTube, OChem naming. This is on page, let's see, 22 of the reader. It looks like this, okay? Or it's on page 96 of the textbook. The basic thing about organic compounds, and we're going to do the simplest of all, even your book goes into more detail than we will in lecture. You basically just need to know how to name what we're going to call, what is called straight-chained alkanes. So let me show you how to do that. It's actually pretty simple. So this is organic nomenclature, or naming. Organic generally is agreed upon to mean carbons and hydrogens. It could be more. So, for example, let me write down a couple compounds here. Okay? This, all you're going to do is you're going to put the prefix followed by the suffix A and E. And the prefix is what designates the number of carbons. Don't worry about the number of hydrogens, we care about the number of carbons. So, in this case, 1 carbon, METH. So this first one is methane. Methane. 2 carbons in the next one is the prefix F, ETH. This is called ethane. 3, just like propeller, for 3, propane. Or if we kind of jump up a little bit, C8, H18. For 8 carbons, it is octane. For high octane gasoline, this is what we're talking about. So it's all, that's all there is. You just need to know these prefixes. Okay? So do decane, nonane, octane, heptane, hexane, etc. These come in kind of useful when you watch on TV or you're hearing kind of some science talk and they mention a compound. It tells you how many carbons are there. Like you've heard of meth, or maybe your friends have. This is methamphetamine. It's called, this meth right there is because this 1 carbon group right here. Okay? Or if you watch the news, you might have heard of this. Does anybody know, why is this hot in the news? Water contamination where? West Virginia. Yeah, MCHM, or 4-methyl-cyclohexane methanol. Why are these 2 meths here? The 4-methyl is from this 1 carbon group, and the methanol is from this 1 carbon group right there. So you can, and the cyclohexane is from 1, 2, 3, 4, 5, 6. So you can see these prefixes often in organic molecules. It tells you the number of carbons in that little group right there. So you learn a lot more when you take OChem, but that's, you won't have to name these 2 examples, but you'll just have to name simple, straight-chained alkanes like this. If you're wondering, how do I know how many hydrogens there are? It's always CnH2n plus 2. That means, oh, if there are 6 carbons, how many hydrogens will I have? Yeah, 2 times 6 plus 2, 14. And what would this be called? Hexane. Hex for 6, and then always an A in it. Now, remember Josh, he taught you the bond line formula. So, for example, I could give you that. How many carbons are there? You should count 5. 1, 2, 3, 4, 5. So this is called pent for 5-ane. All one word. Pent-ane. By the way, this would be C5H what? 12, yeah. 2 times 5 plus 2 is 12. Okay, that's it for that category. So now we have 4 types of naked styles. Ionic, molecular, aqueous acid, and the simple organics. You'll see your book also has hydrates, which are a subcategory of ionics. And if you want to know more about hydrates, you can watch this video, but I won't cover it in class. Your intro to lab techniques lab has a hydrate. I believe it's manganese? No. Yes, manganese sulfate monohydrate, I believe. Something like that. Okay. We did it. I think we're done with chapter 3. Let's see. Yes.